Hi, today you're going to learn all the things listed on screen. So you've made this really cool Vellum simulation and you want to render it in Unreal. What do? Well, we're going to be exporting as Alembic, so you drop down an Alembic ROP at the end of your chain. But before you export, you want to make sure that your simulation has UVs, and you want to delete all the attributes that Vellum creates for you. So in my case, I'm only keeping the position and the color and the UV attributes. And you want to delete all the groups that Vellum creates as well. This is just so we don't get a heavy Alembic file. Then to suit Unreal Engine's coordinate system, we rotate the entire simulation 90 in X and we scale it uniformly by 100. Then you're ready to export, set your frame range, press save to disk, let's go to Unreal. Now we've opened Unreal and we're going to make our project. So you want to go to the games preset. I like to choose the third person template. That way I have a mannequin that I can create my environment around to make sure that the scale is correct. You want to make sure that you've ticked on ray tracing. We're going to rename the project. You press create. Before we do any fun stuff inside of Unreal, we need to do some housekeeping because Unreal is a game engine. It's not necessarily set up for our render purposes. You're gonna go up here into the edit menu, go to project settings. We're gonna search for a few things. Search for Lumen, which is the lighting system. You wanna make sure that use hardware ray tracing when available is ticked on. Search for ray tracing. Make sure that ray traced shadows and ray traced skylight are both enabled. Search for height fog. Make sure that support sky atmosphere affecting height fog is enabled. We need to enable the plugin that allows us to render. You go to edit, plugins. We search for movie render queue. Enable that. Unreal will ask you to restart. Press restart now. Reopen the project. We're going to create our own level. You want to go to file, empty level. Now that we have our level, we're going to import our Alembic file. We're just going to create a folder called ABC. Drag and drop our Alembic file from Explorer to Unreal. Now we're met with this import options window. You want to make sure that import type is set to geometry cache. Everything else is left to default. Just make sure that create materials and find materials are both disabled. Import. We can now drop it into our level, so we're just gonna drag and drop into our level. We see a still mesh. It's just our first frame. In order to just quickly check that everything is okay, you click on it in the viewport or out here in the outliner, inflated tubes. You go to start time offset, you just scroll through it a little bit and you can see there are other frames. It's working. Reset this to 0. Before we do anything else, you just want to press save all to make sure that your new asset, the Alembic cache, and your new level are both saved in case of a crash. Press save and it's going to ask you where do you want to put your level. We're going to make a new folder and we're going to call it levels and we'll name this to L_tutorial. Save it. We need to create a light so we can see something. You go up here to the little plus and the cube lights. We want to put in a rectangular light. Move it up, press E to get the rotation gizmo. We need to see the simulation. We need to create a level sequence. You do that on this button up here. Press add level sequence and we're going to create a new folder called sequences. To put this sequence in, we're going to name it S for sequence, inflated tubes underscore shot SH010_01. That's our take number. We're going to save. This window is going to pop up. Press this little camera button here to add a camera to your sequence. This gray icon here next to the camera is the camera that you're currently piloting. So pressing it makes us go back to the default camera, and pressing it again, having it highlighted like this, means that we're now looking through it. When we're moving around in our viewport now, we're moving this camera. Now that we have the camera, we need to take the geometry cache from the outliner and drag and drop it into the sequence. That creates this track here, but you can see still nothing is happening. You need to press this plus button and add another track underneath. And this is the geometry cache track. This is what will make it move. When we scroll, we can now see our simulation is moving. Great. Now you see I dropped mine down at frame 41. I don't want that. I want it on frame 0. So I'm just going to press it and drag it over to frame 0. Our sequence is too long, so it's going to go back to frame 1 over here at the end. We don't want that either. So we're just going to drag this red line here to frame 96, which is the end of our simulation. The sequencer says 30 FPS. Houdini by default exports at 24 frames per second. So we want to just press this and lower it to 24 FPS. Everything should still match up just fine. We press play and you'll see it moving. If we go out of this cinema camera, We press this little button down here. We enable looping. So we just press play again. And we can move our camera in real time while our simulation is running with lighting and everything. Pretty cool. One thing that we've yet to do is apply materials. When you have something selected in Unreal, you get this details panel. The materials. Right now we only have one material slot, and we're not going to be able to take a material and drag it onto just this tube. We need to do some preparation in Houdini in order to do that. So we're going to return to Houdini now and set that up, and then we're going to re-import the simulation with all the updated attributes that it needs in order to create more material slots. We're back in Houdini to set up multiple material slots, and we're also going to add color attribute to the points so we can use that in our materials in Unreal. The color attribute is just at CD, and material slots are just primitive groups. So if you know what to do from here on, you can just skip ahead. I packed the geo so I have 1 point per connected object. Then I made a random attribute called select. I wrote this bit of Vex code to group them into 3 different groups. To apply the color, I've used a attribute adjust color, set the pattern type to random, made this color random. In the unpack, you want to make sure that you keep a few attributes. So you want to keep the color attribute, you want to keep the name attribute, and you want to keep the 3 groups. Drop down a group promote and promote the 3 groups from point to primitive. One really important thing is that you need to delete all the groups that you're not using for this material slot thing. Any primitive group will become a material slot in Unreal. So if you have this Vellum object primitive group, it's going to overtake all the other groups that you've tried to create as material slots. Gonna go to our Alembic ROP, save to disk again. Once your export is done, we can re-import the Alembic in Unreal. Locate it in your content browser, you right click it, re-import. All the settings should be the same, import. If you have the simulation selected in your outliner, you now have 3 material slots. Now we need to create some materials. We're just gonna right click here, we're gonna make a material, name it M_Vertex color _ master. Double click it, this should be pretty familiar. We wanna get the vertex color, so we're just gonna search for vertex, and vertex color is gonna pop up. Plug into the base color. Now we'll press save. The material is gonna compile. We'll drag and drop this material into the 3 elements of our simulation. We have colors now. I don't want them all to just use the vertex color. I want some of these tubes to be metallic and some of them to be cloth using the vertex color. We're gonna make a new material, name it M_gold, and double click to open the gold. First of all, you press 1 and left click in here to drop down a constant float. We'll set that to 1 to make this material metallic. We want a base color. We're gonna press 3 and left click. We're gonna right click it and convert it to parameters. We'll name this base color. I'll plug that into the base color. Here we'll just set this to white as the default color. Press save. We also want to set parameters for the roughness. Drop down a scalar parameter by holding S and left clicking. We're gonna name this roughness. We'll set it to a default of 0.1 and save. In order to change any of these parameters on the fly, we need to create a material instance. So we're gonna right click on the material gold. We're gonna create material instance, and we're gonna name that mi_gold for material instance. Double click on mi gold, and now we get this window. So you're just gonna enable these 2 parameters and click here to get this color picker. We're gonna go for something gold. Plug that in. Again, drag and drop, put it on these. Now that is way too shiny. I'm just gonna up this roughness value. That's better. So in order to make this look like cloth, we probably need a normal texture. You can just import normal texture. Once you've located your texture in the Windows Explorer, you just drag and drop it into Unreal, like so. You just need to check something, so double click it, open it up in this window. Under compression settings, you'll see it set to default. We need it to be set to normal map. Save that. Go back into our vertex color master. Drop down a texture sample parameter 2D. We're gonna name that normal. It has this default texture. We're just gonna change that to the default normal, plug that into the normal. In order to use this, again, we need to create a material instance. I'm gonna name that material instance cloth, because this time we're making cloth. Enable normal and just change this to your imported texture. In my case, it's this fabric 01 normal. Search for fabric here, save. Okay, so let's see how that looks. We forgot to put our material instance onto our object, so we're just gonna do that straight away. We need to do a little bit of UV math. So we're gonna go back into our master material, drop down the texture coordinate. We just want to multiply by a scalar parameter. So hold S, drop down scalar parameter, call it tiling. We'll set the default value to 1. and plug it into the B input, then into the UVs of this texture sample node. So we're gonna save that. Now you can open the material instance and you'll see you get this global scalar parameters value and it's tiling. You'll be able to see that the size changes. Open our sequencer from here. If you go to cinematics and sequencer and then go to the camera again and press play. So now we're just going to do a little bit of a camera animation, then we're going to render out. To start doing a camera animation, we're going to set a keyframe on the camera's transform, which is down here. You press this little round button and a keyframe is set. We move the play bar over to the end of our timeline. We set a keyframe here. We're going to move our camera a little bit. I want these tubes to be a bit more over on the left side of the camera. And then I'm going to set the keyframe again. We'll try to play this through. I like that. With your camera selected, you should go to the details panel as well. Go to focus settings, check draw debug focus plane. That way you can see where the focus plane is. Decrease the manual focus distance to something that suits your scene. I'm going to disable debug focus plane. To render, you need to go to window, cinematics, movie render queue. We need to add a job. We do that by pressing the green render button here, and then we select our sequence. You need to set the render settings under the unsafe config. We are in this case okay with a JPEG sequence. I would normally render EXR. We need to add an anti-aliasing setting, console variables, game overrides. Under anti-aliasing, you want to set the temporal sample count to 8. Enable override anti-aliasing. Under advanced, increase the engine warm-up count to 12. Console variables is a really big topic and I'm not going to go too deep into it now. Here on screen you'll see the ones that I commonly use. They simply just up the quality at render time in comparison to what's shown in the editor. Under output, you see your output directory right here. So once you're happy with your settings, you can go here to load/save preset and you can save these render settings as an asset within your content browser. I'm going to save this under sequences, then I'll load that up, press accept. So now everything is ready and you just need to press render local. Thank you for listening. I hope you learned something. If you have any questions, please let me know and I'll do my best to answer them. In the background, there are some clips of works that use a process that builds on the foundations that you will have learned in this video. And I will cover something like that in later videos.